Hello guys, welcome to the first episode of System Design Parichay. Let us start from the very start. Let's try to understand the word system and let's try to answer what system stands for in system design. A system is a group of components that work together to produce some output. So you can think of a juicer where you input some fruits or some vegetables, it processes or grinds the fruit, and then you get the output, which is nothing but the juice. So in the same fashion, a system can be a huge component or a set of component which gets some input, processes the data or the input, and it gives us some output. So that we can conclude as a system. Imagine you have started your cafe. Initially, there are very few customers. There's only one cook and you have very small menu, and on top of it, you have only one billing counter. Now, initially, you can serve around 10 to 20 people or 10 to 20 guests in a day, or it can go up to 30-40 guests. But imagine you are anyways doing great, the food tastes good, the hospitality is really great, and the cafe is really good. And your cafe goes viral on social media, and suddenly there are thousands of people who want to come and eat at your cafe. Now, what is going to happen? It is going to be a chaotic situation, right? What will happen? Number one, there are going to be a lot of long queues. Second, what is going to happen? Orders will start getting delayed, or even worse, orders might get mixed up. There could be long payment pending issues, and congratulations. Now you have got your first issue of your cafe, which is scalability. So in a nutshell, let's try to understand what exactly is a scalability issue. In scalability, something works fine. It can be your system or it can be the service that you're offering. Works fine only for a few people or some request. But when a lot of people try to use it or a lot of request comes and tries to hit your service, it generally doesn't work well or it takes a lot of time. So that is your scalability issue. Let's come back to our cafe. So in our cafe, we have one juicer machine and the orders are 10. Let's suppose there are 10 orders that we need to serve in our cafe, but our juicer machine can only make 5 juice glasses at a time. Now this is the concept of throughput. Throughput is nothing but how many things can be finished in a certain amount of time. So in order to fulfill the order of 10 juices, we have to run our juicer machine twice. So this is nothing but a very good example of throughput. Availability means how often the service is available when you need it. So for example, in your cafe, your cook is very hardworking, but he or she needs break. So let's say they are available for 12 hours a day, but for 12 hours, there is no order which is getting processed or served. So here is the concept of availability. In your system, how often the system is running or is available for the request to render or to process something or to process any request which is coming to the system. Imagine you went to a shop and you bought a calculator. You come home and you type 2 plus 2 and the calculator shows up 5. So here we know that the calculator is not reliable. Similarly, in a system or in system designing, when we talk about reliability, it is how often something works correctly without making any mistakes. So congratulations, you have learned another topic, reliability. Imagine you are going on a road trip with your friends to Goa. Now suppose if one of the tire of your car gets punctured, will you stop your trip? No. What you're going to do? You're going to replace that punctured tire with a stepney or spare tire. Now here, your car has become fault tolerant. In the same sense, in a system, when something stops working, the entire system doesn't stop. The entire system keeps on processing and giving us the same output. That is fault tolerance. Consistency means everything or every small component of your system should be able to see the same information which is updated or which was raw. That is no confusion and no mismatch. So for example, let's suppose you have 2000 rupees in your bank account. You did a transaction of 500 rupees via UPI. And now if you want to check the balance, you check it through UPI, the balance will be 1500. You went to an ATM and you check your balance, it should be 1500. And if you went to bank and you check your passbook, you updated the passbook, the balance again will show 1500. So it means all the components of the system or everyone should see the updated information and there's no mismatch across the entire system. Durability is once something is saved, it should remain forever and it should not be lost. Even if the power goes off, if the system crashes, or even if your system restarts. That is, the data remains forever or the information is saved forever. For example, let's suppose you go to a bank and in the bank you deposited 1000 rupees and suddenly there is a server outage, that is, the bank server is not working, or they are doing some maintenance, or there are some other issues with the server, but your updated balance must be there and it should not get zero. That is durability. In a nutshell, durability is equal to data stays forever. Congratulations everyone on reaching to the end of this video. We completed 8 topics which are very much important to start your journey, and now you guys are way ahead compared to the beginners in system design journey. To study further topics of this series, watch second episode in our channel and I'll see you guys there.